Good morning, dear students. Am I audible? Hello? Am I audible? Somebody please respond.
Yes, sir.
Yeah, thank you. Yeah. So today, let's get started with today's session. So today in the agenda, we have fragmentation, that is packet fragmentation and reassembly. So we'll discuss about this concept. So yesterday, we have discussed the internet working. So basically, the problem with bridges are limited to only interconnection of homogeneous networks, similar kind of networks. Whereas the networks that connects heterogeneous networks, we call it as inter network. So this can be achieved through gateways or routers. Routers are being used, and gateways are being used. So that is what we understood. And the small I we write to represent internet, and capital I we write for internet. It is to represent the global collection of networks. It is to global connection of networks. So we have taken one simple example how exactly different computers, different networks, computers can be connected. So here in network 1, we have wireless network. In network 2, we have LAN network. So wireless network and LAN network, that is Ethernet, can be connected through router R1. And again, LAN Ethernet is connected to router 2, and router 2 to router 3, there is a network, we call it as point-to-point network. And finally, router 3 is connected to router 4. So this is how you can certainly have. So network of networks, various networks. So inter-network we discussed. And when we want to transmit data from, consider, let us take an example of network that is having network that is having wireless network. Suppose you have a host, at H5 is your host, and from this host I just want to transmit data to H8. So H1 to H8, if you want to transmit, what happens? The data should go to your Ethernet, that is 802.11, that is Wi-Fi data. It has to convert to Ethernet data. Ethernet data is converted at R1, and R1 connects again Ethernet data to next further PPP, that is point-to-point network. So it converts at R2, the transmission and the conversion of packets used to happen, and from R2 to R3, that is from R3 to LAN, that is again from PPE to Ethernet, it is converting, and finally converted converted data again, packet is converted back to Ethernet. So this was the scenario yesterday we saw. Today we see fragmentation, same. So while transmitting all these things, you should understand the fragmentation is quite necessary, because the packet size is very big. The packet size is very big, and when you want to transmit data from one network to another network, definitely these packets will have to go through different networks, and finally we should reach. So one of the problems of providing a uniform host-to-host service model or a heterogeneous collection of network is that each network topology tend to have its own idea of the packet format. So definitely, if you look at the frame format of 802.11, that is Wi-Fi, is totally different from 802.3, that is Ethernet. And from point to point network, it is totally another different way. So, and again, Ethernet, it is a different way. So you have different types of LANs, and they have different formats, but you have to connect all those things, and you have to communicate. So the major problem is they have different networks have different frame formats or packet formats. And of course, example, Ethernet packet can accept up to 1500 bytes. The capacity of Ethernet is 1500 bytes, the frame format. Whereas fiber optics, FDDI, fiber distributed data interface, it will take the packets around size of 4500. So you see, definitely there is a transition. So if you want to connect FDDI to Ethernet, or Ethernet to FDDI, or Wi-Fi, so definitely there will be a change in the packet format. So the packet format change has to be taken care by this routers. Routers are the one which connects these heterogeneous networks. So understand, this leaves two choices for IP service model. First one, make sure that IP datagrams are small enough to fit inside one packet on the network, any technology. So create a common frame format, create a common frame format or packet size, so that every network will be followed, and there is no problem with respect to transmission of data. So that is, but it is not practically possible. So having all the packet size same is not at all possible, because you have to change the entire protocol, so which is not at all permitted. Entire protocol change is not at all permitted. So definitely what we will do, we will follow another method. Provide a means by which packets can be fragmented. Yes, if it is a big one, it has to be split into smaller ones. It is fragmented, and at the receiving station, they can be reassembled. So this is another point that you should always understand. So one way, making either it is a FDDI network, or Ethernet, or Wi-Fi, or point-to-point network. So make a uniform size. Uniform size, making uniform size is not at all possible, right? So definitely we have to go for the second option. What is the second option? Suppose if higher size packet, if it is transmitting in the lower network, so definitely what happens, the higher size packet is split into various fragments, smaller packets, and these smaller packets are transmitted at the receiving station. What happens, these packets are reassembled to form the original message. So that is one option that we have. So definitely the second option works out, because the first option we cannot certainly work it out. We cannot change the protocol, the structure, the size, the format, we cannot change. So the second one we can follow. So what is that we are doing? The central idea is that every network type has a maximum transmission unit. We call it as MTU. Every network has MTU, which is the largest IP datagram that it can carry in the frame. So that can be done. So, and when the host send a IP datagram, therefore it can choose any size that it wants. And of course, the reasonable choice, the reasonable choice is to set the MTU, maximum transmission unit of the network, to which it is host is directly attached. So normally the sender can decide what may be the size of my packet. So he can send, and he decides and he sends the packet. During the course, if it encounters the smaller size network, automatically what happens? A fragmentation. Then fragmentation will only be necessary if the path of the destination includes the network with a smaller MTU. You have a network with a smaller MTU, transmission unit, smaller transmission unit. The packet size, if the packet size is small, so certainly we can achieve that. So that is another thing that we should consider. And fragmentation typically occurs when a router, when it receives a datagram, uh, and of course that is it wants to forward over a network that has an MTU that is smaller than the received datagram. So always remember, MTU, maximum transmission unit, should be the smallest datagram that is ever possible in the network. So in a network, so that can be chosen so that we can avoid a fragmentation. We can avoid fragmentation and other things. Of course, to enable these fragments to be reassembled at the receiving host, all the all carry the same identifier in the identity field. Yesterday we saw in IPv4 frame format, we had a what we call it as a field called identify field. So in the identify field, so we can certainly write the field number. So packet number, the fragment number. When you write the fragment number, it becomes very easy. It becomes very easy, and it can be reassembled at the receiving station. So that can be done. This identifier, the identification number, what you give, is chosen by the sender host, and it is handled to be unique among all the datagrams that might arrive at the destination from this source over some reasonable time of some reasonable period. So this is been this is what we have to understand. So the identifier, or the what do we say, the number, fragment number, or the packet number, is going to really help during the assembly of the particular packet at the receiving station. So since all the fragments of the original datagram contain this identifier, the receiver, the reassembly host will be able to recognize those fragments that are go together. So it becomes very easy for the reassembly host to arrange back all these frames together. So look at this diagram. So when we are sending a packet, so host 5 to host 8, we want to transmit the data. When we transmit the data from host 5 to host 8, what happens? Host 5 gives the fact, it is in 802.11. 802.11 means it is Wi-Fi. Wi-Fi packet size is 1400. Yes, the size of the packet is 1400. So when it transmits through Ethernet, okay, Ethernet is 1500, 1400 will easily transmit. There is no problem. So the size will be retained as it is. But when it comes to PPP, point-to-point network, the maximum data capacity of PPP is only 512. So what happens? 1,400, packet will be split into, three different, packets, 500, 500, and around, 300 and something. So three packets will be, split, and it will be transmitted in, PPP, point to point, and finally the same PPP packets will be sent. So here fragmentation happens. Look at here, the fragmentation happens here in router 2. So fragmentation happens. So 1,400 bytes are fragmented into 512, 512, three, fragments, and it will be transmitted. And R3 will never, bother about the fragments. Anyhow, fragments, the packet is coming 512 byte, 512 byte, it has to be sent through Ethernet, 512 byte, it will accept, so it will transmit all these 512 byte, 1 second, third, will transmit, and finally in H8, what happens? Total reassembly happens. Reassembly happens at the host 8. So host 8 will reassemble the packets. Host 8 will reassemble the packets. So this is what we understand. So whenever a network, particular network, sender network is having packet size of higher bytes, so when it transmits through lower capacity networks, automatically the entire frame is split into fragments, and each fragment is transmitted, and finally at the host station these fragments are reassembled. That's what you have to understand. So look at this particular sentence to see how exactly all this happens. Let us take H5 sender datagram to host 8 in the example of internet network. So here in the diagram, and of course assume that we have an MTU of 1,500 bytes for 2 Ethernet in 802.11, and of course 532 bytes of point-to-point network, and a maximum size of 1,420 for Wi-Fi network. So what happens? H5 sends 802.11 network, the first frame without any fragmentation, it should go, because 1,400 plus will easily fit in 1,500. Yes, it can easily fit. So it will transmit as it is. And when it comes to router 2, again router 2, it cannot transmit as it is just like that. So what happens? It has to be cut down into 3 parts or 3 fragments, and this will be sent. So, and finally at the receiving station, H8 will reassemble the entire frame. This is what we have to understand. So this is a fragmentation and reassembly. And in the examination, if they ask explain procedure of fragmentation and reassembly, you have to give an example like this, and you have to explain. So that's all for today's class. We'll discuss global addressing, that is different classes of IP address, in the next class. So the entire class video will be available on this particular website, and on this study material. Now we'll do a short quick revision. So when we